The ocean was never designed to be a factory. For most of human history, it was unpredictable, seasonal, violent, generous, and uncontrollable. Fish appeared and disappeared according to currents, temperature, and chance. Coastal communities adapted. They waited. They followed migrations. They accepted uncertainty. That world no longer exists. Today, the ocean is mapped, measured, monitored, and scheduled. Satellites track its surface. Sensors listen beneath it. Algorithms predict what will grow, where it will swim, how fast it will mature, and when it will be harvested. Fish are no longer only caught. They are produced. In the global food system, seafood has become one of the most engineered sources of protein on Earth. Two species represent this transformation better than any others: Atlantic salmon and sardines. One is cultivated in controlled underwater farms, raised from egg to harvest like a biological manufacturing process. The other is extracted from the open ocean using industrial fleets, radar systems, and floating factories. Different methods, same logic: scale, predictability, efficiency, and total integration into global supply chains. Every year, millions of tons of fish move from cold water into refrigerated containers, processing plants, cutting rooms, smoking chambers, canning lines, and finally into supermarkets thousands of kilometers from where they were born. To the consumer, seafood appears simple: a fillet, a can, a plastic tray. But behind that simplicity stands an infrastructure as complex as any modern industry. Floating cages the size of football fields, automated feeding platforms, underwater cameras, genetic selection programs, deep-sea nets stretching for kilometers, factory ships operating without touching land for weeks, processing plants that handle tens of thousands of fish per day with surgical precision. The ocean is no longer only an ecosystem, it is a production environment. Norway sits at the center of this transformation. A country defined by mountains, fjords, and cold Atlantic water became the world's largest producer of farmed salmon not by accident, but by engineering geography into an advantage. Cold water slows bacterial growth. Strong currents oxygenate cages. Deep fjords protect infrastructure from storms. What nature provided, technology optimized. At the same time, across the Atlantic and the Pacific, fleets chase sardines using tools that resemble military equipment more than fishing gear. Sonar scans the darkness. Radar locates moving biomass. GPS coordinates replace intuition. Schools of fish appear on screens as dense clouds of data before they appear on the surface as living animals. The difference between farming and fishing is shrinking. Both are becoming industrial extraction systems. Both are governed by software. Both depend on energy, logistics, chemistry, and global trade. Both exist to feed cities that no longer touch the sea. In this system, fish are not measured by beauty or wildness. They are measured by weight, fat content, growth rate, mortality ratio, conversion efficiency, shelf life, market price. A salmon is no longer just a fish. It is a biological unit of production. A sardine is no longer part of a moving ecosystem. It is a unit of harvestable protein. Their lives are shaped not by instinct, but by design. Eggs selected by breeders. Water filtered by machines. Food delivered by algorithms. Growth accelerated by temperature control. Harvest timed to international demand. Even death is optimized. Minimized stress. Maximum yield. Clean separation. Cold storage within minutes. From the first moment of life to the final cut of a blade, the modern fish exists inside a system that does not sleep. The ocean still moves. Currents still shift. Storms still rise. But above and below the surface, machines now watch, adjust, and correct. Nature provides the raw platform. Industry writes the rules. And somewhere between cold water and stainless steel, seafood becomes infrastructure. Not food from the sea. Food from a system built on top of it. Salmon farming does not begin in the ocean. It begins in silence. Inside sterile rooms, far from waves and salt, where water is filtered, temperatures are fixed to decimals, and light is controlled like a laboratory experiment. Here, salmon exist first as numbers. Genetic lines, growth curves, disease resistance scores, fat distribution models. Broodstock are selected not for survival, but for performance. Which fish grows faster? Which converts feed more efficiently? Which resists parasites? Which produces flesh with the color markets expect? Eggs are extracted, fertilized, disinfected, and stacked in trays under constant surveillance. Sensors monitor oxygen. Software adjusts flow rates. Technicians watch for microscopic signs of fungus. At this stage, a salmon is not a fish. It is a biological project. Weeks later, the eggs hatch into larvae. They absorb their yolk sacs under artificial light cycles designed to accelerate development. When they begin feeding, machines dispense micro-pellets with precise protein and lipid ratios. Growth is measured daily. Deviations trigger alarms. Weak individuals are removed. Uniformity is the goal. Variation is waste. After months, the juveniles, now called smolts, are transferred into massive tanks where freshwater slowly becomes saltwater. This transition is engineered. Salinity rises by fractions. Temperature shifts are scheduled. Hormonal changes are induced to prepare their bodies for the ocean. Nature used to decide when salmon were ready. Now, spreadsheets do. When the smolts reach target size, they are loaded into specialized vessels. Live fish transport ships, floating tanks with oxygen injection systems, water circulation, and real-time health monitoring. They travel through fjords toward offshore farms. What awaits them is not wilderness. It is geometry, circular cages, steel frames, tensioned nets, anchors drilled into the seabed. Each cage can hold up to 200,000 fish. From above, the farms look like floating cities. From below, like suspended factories. Automated feeders hang above the water, guided by cameras that track fish movement. Pellets fall only when software confirms active feeding. Too slow means hunger. Too fast means pollution. Algorithms decide. Underwater drones patrol the nets. They inspect for holes, remove parasites, scan for abnormal behavior. Every fish becomes data, weight estimates, health probability, feed conversion ratios, mortality projections. If growth slows, temperature models are adjusted. If lice appear, chemical treatments or cleaner fish are deployed. Wrasse and lumpfish, small species introduced as biological tools, swim among salmon-eating parasites. Even the ecosystem is outsourced. Storms no longer stop production. Cages are reinforced. Mooring systems are calculated for extreme waves. Backup generators power feeders during blackouts. Harvest schedules are planned months in advance based on futures contracts. The salmon will reach 5 kilograms in 14 to 18 months. Not approximately, precisely. When the date arrives, boats move in. Nets tighten. Fish are pumped on board through vacuum tubes. Stunned, bled, chilled, all within minutes. The goal is not speed. It is consistency. A fillet in Tokyo must look identical to one in Paris. Color charts define acceptability. Texture is measured. Fat layers are standardized. Nature rarely produces identical things. Industry demands it. Norway produces more than half of the world's farmed salmon. An animal that once crossed oceans freely is now born in plastic trays, grows inside steel circles, and dies according to shipping schedules. It never knows rivers. It never migrates. It never chooses. Its entire existence fits inside a supply chain diagram. Efficient, predictable, profitable, and invisible to the consumer. On a supermarket shelf, the salmon is silent. Pink, clean, neutral, no hint of the sensors. The algorithms, the underwater factories, or the quiet moment when its life became a production variable. Salmon are engineered, sardines are hunted, not by fishermen with nets and instincts, by machines that see through water. Modern sardine fishing begins in the sky. Satellites track sea temperature, chlorophyll density, current patterns. Algorithms predict where plankton will bloom. Where plankton blooms, sardines gather. Before a single boat moves, the ocean has already been mapped. Fishing companies receive digital coordinates, probability heat maps, risk models, fuel optimization routes. The hunt is scheduled. On the water, vessels no longer search. They confirm. Gigantic purse seiners patrol pre-approved zones, equipped with sonar arrays capable of detecting schools hundreds of meters below the surface. A sardine school appears on screens as a living cloud. Density, depth, speed, direction. Software estimates total biomass within seconds. Is it worth catching? If the numbers are too low, the ship moves on. Protein must be efficient. When the threshold is met, deployment begins. A small boat releases one end of a massive net. The main vessel circles the invisible cloud. Closing geometry around biology. The net sinks, slowly, quietly, then tightens from below. What was once an ecosystem becomes a container. Thousands of fish compress into a silver spiral. Water churns, oxygen drops, survival time is calculated, cranes activate, vacuum pumps lower into the mass. Fish are suctioned onboard in liquid streams. Not lifted, transferred, like grain. Inside the ship, the factory is already running. Sorting machines separate by size. Smaller sardines for canning, larger for fish meal and oil. Quality scanners remove damaged bodies. Conveyors move non-stop, humans supervise, machines decide. Below deck, stainless steel lines process flesh at industrial speed. Heads removed, guts extracted, bodies washed, steamed, cooled, packed, sometimes within the same vessel. Some ships never return with raw fish. They return with finished product. Floating food plants. Waste is redirected. Bones and organs become fish meal. Fish meal becomes livestock feed, or aquaculture feed. Sardines feed salmon. Salmon feeds humans. The loop closes. Nothing is wasted. Everything is monetized. By the time the ship docks, millions of fish have already been converted into pallets of identical metal cans. Labeled, barcoded, destination assigned, Africa, South America, Europe, emergency food programs, supermarkets, military contracts. A sardine lives less than 3 years. Its industrial life lasts less than 3 minutes. From ocean to container, from animal to inventory, overfishing used to be accidental. Now it is modeled. Governments set quotas. Companies simulate compliance. Sensors track catches in real time. If stocks drop, fleets relocate. New waters, new coordinates, same machines. The fish do not know borders. But the data does. In some regions, local fishermen watch their waters emptied by ships longer than football fields. Their wooden boats sit still. Fuel is expensive. Their nets are small. Their sonar is their eyes. Industrial fleets leave behind quiet water. And spreadsheets marked, successful operation. On land, a consumer opens a can. Oil glistens, perfect alignment, no smell of salt or blood, no hint of satellites, no memory of the moment a living cloud collapsed into a tightening circle of nylon. Just protein, cheap, stable, efficient, a product that looks simple. Because complexity has been hidden behind steel walls and data centers floating at sea. The sardine has become a unit, not a species, a row in a logistics system, measured in tons per hour, yield per liter of fuel, profit per square kilometer of ocean. And the ocean, slowly, quietly, is learning to speak the language of quarterly reports. Most sardines are not eaten by humans. They are recycled into animals. This transformation begins minutes after processing. Onboard factory ships or coastal plants, sardines classified as industrial grade are not packed for shelves. They are crushed, cooked, pressed. The liquid becomes fish oil. The solids become fish cake. Both are dehydrated, ground into powder. This powder is fish meal. It looks harmless, like sand, smells faintly of the sea. But it is the backbone of modern protein production. Fish meal is pure density, up to 72% protein. Rich in omega oils, loaded with minerals, perfect for fast growth, perfect for controlled biology. Trucks carry it inland, to feed mills, to aquaculture facilities, to poultry farms, to pig operations, to places where animals no longer touch soil. Inside massive feed factories, fish meal is blended with soy, corn, enzymes, synthetic amino acids, and vitamin packs. Algorithms balance formulas: growth speed, muscle density, feed conversion ratio, waste output. Every gram is calculated. Animals are no longer raised. They are optimized. In aquaculture, this loop becomes extreme. Farm salmon are carnivores. They require marine protein, so wild sardines become food for captive fish. Open sea protein is converted into controlled tank protein. One ecosystem feeds another, not by nature, by design. In Norway, Chile, Canada, and Scotland, salmon farms float in cold water grids. Tens of thousands of fish per cage. Sensors track oxygen, waste, temperature, growth rate. Automated systems release pellets made from sardines that once swam freely. This is protein conversion at planetary scale. It takes 3 kilograms of wild fish to produce 1 kilogram of farmed salmon. Efficiency, according to accounting. Extraction, according to biology. The same system feeds chickens in Brazil, pigs in China, shrimp in Vietnam. Fish from Peru becomes pork in Shanghai. Ocean calories become land calories. Geography collapses. Only logistics remain. Entire countries exist to feed this loop. Peru alone produces millions of tons of fish meal each year. Almost none of it stays there. It is exported, to feed animals elsewhere, to support diets built on abundance, to stabilize meat prices in cities thousands of kilometers away. When anchovy stocks collapse, global meat prices move. When ocean temperatures rise, chicken becomes expensive. The supermarket is connected to plankton, but the customer never sees the line. Fish meal factories run day and night. Huge rotating dryers, steam columns, grinding chambers, Conveyor belts of beige powder flowing into shipping containers. No branding, no storytelling, no romance, just bulk protein in anonymous sacks. The smell never leaves the workers' clothes. The dust settles into lungs. The noise never stops. Fish meal is invisible food. You never order it, you never taste it directly. But it lives inside eggs, inside burgers, inside salmon sushi, inside pet food, inside everything that walks, swims, or flies and ends up wrapped in plastic. It is the hidden infrastructure of modern nutrition, a shadow ingredient, and it depends entirely on oceans that regenerate slowly. Companies call it resource management. Reports use words like sustainability, optimization, renewable yield, but fish reproduce on biological time. Markets move on quarterly time. When stocks decline, ships move deeper, farther, longer, new coordinates, new species, same grinders. The ocean becomes a warehouse. Its shelves are schools of fish. Its inventory tracked by satellites. Its depletion measured in spreadsheets. Fish meal does not look violent. It is dry, neutral, industrial, but it represents a choice. To turn living systems into fuel. To feed one animal by emptying another habitat. To convert motion into mass. Life into numbers. By the time meat reaches a plate, the sardine has already disappeared twice. First as a fish, then as powder, its existence reduced to growth statistics in a corporate database. And the loop continues, quietly, efficiently, feeding the world. By consuming the ocean, fishing is no longer about boats. It is about data. Modern fleets operate like moving server farms. Satellites map plankton blooms. AI models predict fish movement. Ocean temperature layers are scanned in real time. Currents are simulated days ahead. The fish are found before they arrive. Captains no longer hunt, they execute coordinates. Vessels receive routes optimized for fuel burn, catch density, and processing capacity. Net depth is calculated automatically. Haul timing synchronized with onboard freezing systems. Human judgment is optional. Software is mandatory. Some ships never dock for weeks. They process everything at sea. Head removed, organs extracted, muscle separated, waste liquefied, protein dried, oil filtered, everything measured, nothing wasted, nothing respected. Fish become input, output becomes commodity, the ocean becomes a production layer. Companies now test autonomous fishing vessels. No crew, no wages, no fatigue, only maintenance cycles. Robotic nets deploy, sensors confirm biomass density. AI decides when the school is profitable enough to erase. This is not fishing, it is resource harvesting by machine intelligence. And the next step is already here. Synthetic seafood. Labs now grow fish muscle without fish. Cells extracted once, replicated forever, fed with nutrient broth, shaped into fillets, printed into texture. No ocean, no bones, no blood, no seasons. Bioreactors replace tides, warehouses replace coastlines. Protein becomes software, scaled like cloud computing. Companies promise zero overfishing, zero bycatch, zero ecosystem damage, and near zero cost at scale. Real fish will become luxury. Wild salmon will be auction items. Sardines will exist mainly as genetic templates. The rest will be cultivated matter. Designed flesh. This will not stop industrial fishing. It will coexist. Cheap synthetic protein for mass markets. Wild capture for premium branding. Natural, authentic, heritage protein. The ocean split into two roles, data source, marketing myth. Meanwhile, climate continues rewriting everything. Warmer waters push species north. Spawning cycles break, plankton zones drift, old fishing maps become useless. AI retrains, routes change, nets follow. Biology adapts slower than algorithms. The gap widens, more pressure, more extraction, more automation, less uncertainty, less life. The final version of the system is quiet. No heroic fishermen, no romance, no storms, just steel vessels, silent drones, cold warehouses, and endless containers of protein powder. The future supermarket will display abundance. Cheap meat, cheap fish, perfect consistency, identical texture, identical color, identical nutrition. Behind it, empty coastlines, retired ports, collapsed species charts archived in forgotten databases. People will eat better than ever, with less connection than ever. Food will be optimized, nature will be minimized. This is the trajectory. Not good, not evil, efficient, relentless, unemotional. The ocean taught humans how to harvest life. Humans taught machines how to finish the job. And protein will keep flowing. even when the water no longer does.